All right, welcome back to the help sessions. This is the second one we are holding. So we have a couple of questions already. So the first question that was asked was in the box and pointer diagrams. I actually have another question that was asked in the, what's it called? The forums. So I might address that as well. But to start, let's have a look at the Lab 12. And we have, which one was it? G. Okay, so we have A++. So A++ is the post increment operator. Now, this is probably the simplest form of it, but basically all it means is A equals A plus 1. Now, it kind of means that. However, when using it, let's say, with another variable, so in this case, it's a very simple example. All you need to do is add 1. So if you had a box that said, let's say, had A and it's an int, and it had 4 in it. So this is beforehand. Then on your next diagram, if you had A++, then it's purely A int 5. Okay, A++ is just adding 1. Now, just for your information, this operator doesn't act exactly how you think it will in all cases. So, for example, why is my pen not working? Oh, oops. Go away. So, for example, let's say I have, so for the person that asked about the box and pointer diagrams, is that okay? Firstly, before I go on. Just type yes if it is. Oh, not. Okay, so I just want to also go through a little bit deeper into that. So if we have, let's say, int w equals 4, and then I have int h equals 6. Now, if I have this and then I go w equals h plus plus, what is the value of h and what is the value of w after this operation? Just type it in the chat. If you're going to participate, you need to help me out and give your answers. H and W. Okay, so sorry. So most people assume that W is going to have a 7 in it. Now, this was covered in the lectures, but I'm pretty sure it was. I hope it was. But we need to understand that there is a difference between this and this. So the actual answer is W is going to hold 6 and H is going to hold 7. The reason being is because this is called post increment. This here, on the other hand, is called pre-increment. Increment. So why this works is because we are adding 1 to h here. However, it is done post the operation, so after the operation. So w equals 6, then we add 1 to h. Does that make sense? Now, when we've got a simple example like this, where there is no operation, it's just adding 1, we have no problem, okay? It's just adding 1 to a. However, in this more complex case, we actually are post-incrementing. Now, I doubt you'll see this on the exam, but it's still useful and you need to be careful using it. I'm pretty sure, I'm not 100% sure. So if we change this and I use pre-increment, so if I use plus h, write down what you think the w and h would be this time. Okay, so they both would be 7. The reason being is that the first thing that happens, it's pre-increment. So, the h would be incremented by 1 and equals 7 before the operation. Then you have w equals 7. So this is really careful. You need to be really careful about this. However, once again, for this example, it really doesn't matter. Okay, so just keep that in mind if you are using the pre and post increment. However, by itself, if you were to use plus a here or a plus, because there is no operation here other than it incrementing, the pre and post do not really matter. And so after this operation, it's going to equal 5 no matter what. Okay, and there's no other variable. But when we've got a case where you've got 2 variables and you're setting it and you're using the plus in an equation or an expression, sorry, this is where you need to be careful because you will get different values. Now, the second thing I wanted to cover about box and pointer diagrams was a question raised in the forum. So if I have, let's say, int x equals 4 star y equals the address of x, and actually, let's go back a step. And y equals 6. So if we look at this, if we have a look at this, then our box and pointer diagram is just going to look something like this. Now, all our variables, you'll notice, hold a value, and this is, in this box is the value. In here is the value. Now, as we know from the lectures, each of these variables also has an address. Now, the reason for using box and pointer diagrams is to make a simplified version of, or representation of, the memory, so we don't have to worry about addresses. Okay? But in this case, I'm going to add addresses to these. So I'm going to give this address, actually what I'm going to do first is get rid of that text and introduce a new layer. So that's 4 and 6. And what I'm going to do here is I'm going to give it an address. So I'm going to say this is address 16, and I'm going to say this is address 64. And I forgot the int. Okay, if I change x to equal 6, it just changes the value here. If I tell y to change the value, it will just change the value here. We're just changing values. Now, once we have pointers, we start using the pointer representation. Now, it is just a representation. There's nothing that actually has a big arrow in memory. So if I introduce int z, int star z equals the address of x, let's say. So we create a new variable called z, and it's of type int star. Now, it also would have an address, but we don't usually include this because we don't know this. Okay, this is decided by the memory management viewer. This is decided by the computer. And this is why we use this representation, so we don't need to do this. So I'm going to give it address 124. So this is 4, this is 6. Now, this here, a pointer actually holds a value, okay? Can someone, or can everyone, type what that value it holds is in the chat? What's the value that a pointer holds? So a pointer holds an address value. In this case, it would be holding address 16. Okay? So if we were drawing this out using the longhand form of showing each bit of memory like we did in the lab, if you want to go have a look at that, we'd actually put the value in there. However, to make this easier, because we don't want to have to give each one of these values, instead what we do is just put a dot and then a line here to say this is pointing at this address. Now, some confusion came up with this. So if I have A and then I have Z. So some people got confused with this, and we had A, we had int star, and it also has an address. Now, what address does this hold? So type it in the chat. Cool. So this holds address 16. Okay? The reason being, it is taking this value. Okay? It is taking the value here. The value here is the address 16. Now, with our pointer, we would never, or we don't, it doesn't make sense to point it here. Okay? Because it's saying we want the address of Z. To point it here, we'd have to say we want the address. But as we know, this can only point at ints, not int stars, and this is an int star. So we can't do that. So because it's taking the value, it is also pointing at this address. Okay? So another way you could think of it is this. This isn't a very good representation because it doesn't really mean anything once we go to another function. But this is the address of A, and we're saying A takes the value inside Z. So now this has the address of A. Okay? So be very careful with that. It's not taking the address of Z. There is no address symbol here. Okay? So a good way to quickly check if it should be pointing at the box or not is this address symbol, because then it's saying point at that address. If there's no address, then we're grabbing the value. So we're actually grabbing what's here. So for example, if I say x equals y, or becomes y, it's taking the value here and putting it into here. Okay, so we get a 6 here. When I say z becomes a, we're grabbing the value from here and putting it here. Probably shouldn't use arrows, but I think you get the point. So be very careful with that. And another check is this. We will not put any tricky pointers on the exam. So this is an int star. So what it should be, the only two things that it should be pointing at are these two, because these are ints. So the arrow should only go to either this one or this one. Or it'll be a question mark if it's not initialized. Or it could be null. However, your pointers are not null unless you set them to null. Okay, and that just says that they don't point to anything. Okay, and initially they will still point to something, but we don't know what. So if we want to set them to null, we have to do it explicitly. So we have to say z equals null. Okay, and now it points at nothing. Okay, so just want to be really clear about that. All right. All right. Now, one other thing, I just want to quickly check something. There's two other questions there. So we've got question 18 in week 12 lab sheet, and we've also got question 12 and question 12. I really don't like that question. But I also want to check something else. Now, one other thing I just want to quickly mention is do not forget you've got the quiz questions there. The quiz questions the quiz questions are a really, really good indicator of where you're up to. And also they're similar to what's it called? Well, the week 12 lab, most of the questions are taken from there. And the exact, you'll probably see similar questions for the quizzes as well. So I highly recommend that you do that. All right. So the next question we had, where did I put it? Is question 18 in week 12 lab. Where did I put the lab? Let me see. Question 12. No, that's an easy one. All right. So let's make a new layout. right at the top. So question 12. It's a really, really good question. So we have int game equals 1, and then we have switch game case 0 printf tennis case 1 printf. Like, anyways, I'm going to continue anyway, just to make sure. I've half written it anyway. It's actually a really good question. It's really important. And then I've got f. Printf end of list. I think this was actually someone else that asked this question. All right. Can everyone give what they think the answer is? In the chat? What will be printed?
So Matt, is end of list is within the switch or out of the switch?
After the switch.
Okay.
Would it matter?
Not really.
So, EOF. What? So Ila's point was a good one. If it was in the switch or out of the switch, it wouldn't make a difference. It would still give you the same answer. However, I think everyone's given the right answer. So basically, it would switch to the 1, case 1 is evaluated, and then it just goes down and prints CF, end of list. Okay. Cool. Right. So the next question was, this is question 13. All right. So what we'll go through is we have a question about question 18. So I'd like to know what you don't understand about that. So list what you don't understand, and then we can go through it, just so we focus on what you don't understand. And we also had a question about question 13. So you can just list what you don't understand, and we'll go through it. All right. I might actually see if I can do that. All right. One other question that was asked was about incrementing pointers and incrementing, what's it called? What was it? Pointer gets incremented and when the value gets incremented. So I highly doubt that you'll see anything like this on the exam, further than what you've done with pointer arithmetic. But the question was asked. So you've got a couple of cases. I'm gotta be careful how much I give. So that, let's say, let's say that. So everyone should know what happens here. Okay. So here we're just incrementing the pointer. Now, if our pointer, let's say, was an int, then plus plus will move it up 4 spaces in the addresses. Okay. Now, this is only useful when we've got an array. So it's a pointer to an array, or else we're going to point at something that we don't know what the value is. Okay. And so this is what you've been using with pointer arithmetic. Now, what's it called? Now, in one of the early lectures, maybe you talked about precedence. So this is basically, I'll give you a simple example. 1 plus 4 times 2. So this takes precedence, and then we evaluate from left to right. Now, let's go. What was I going to say? Now, what have we got here? I've got this one here. So this one here, we are going from what was I saying? We're going from right to left because this takes precedence. And so what it means is that the pointer is incremented and then we dereference it. Here, we know brackets take precedence. Okay, so these are the things that happen first. So the pointer is incremented and then we dereference it. We dereference the value, then we increment it. So this one would be incrementing the value. This one would be incrementing the value at the next pointer. This one would be dereferencing at the next pointer, and this one would be moving the pointer and then dereferencing it. So I highly doubt you'll see something like this, but the question was asked. And it can get fairly complex. I try and avoid doing something fancy like that. It's not only, it's pretty ugly. I would just use brackets rather than trying to do something like this. This is a lot simpler, and this is a lot simpler than something like this. But it's just about precedence. All right, so let's see. 42.
So, sorry, Matt, I'm interrupting, but so the third case in which we have taken a bracket and written star PTR, and then outside the bracket we are incrementing the pointer. Okay, so that means first we will dereference the pointer, and then we are going to increment the value of the dereferencing stuff. Like,
yes,
if suppose we, yeah.
Because brackets always have highest precedence. So this
Yeah,
happens
yeah,
first.
yeah, right.
Where
Yeah. So,
this, on the other hand, well, actually, this, on the other hand, the pointer is incremented and then we dereference it. So nothing, the value doesn't get incremented. But
but
as I said,
in the first case, so if suppose we are writing like, if suppose we are assigning address of x to pointer, and
yes,
if suppose at
x would be
x,
incremented.
yeah, so x is going to be incremented, right?
Yes,
Yeah. Okay. Thanks.
that's all right. Don't stress about it though. I'd be focusing on other things. As long as you understand that brackets happen first, you should be able to work out that. All right. So 42. What's 42? Huh? All right. So what are we looking at? So question 13. What was the problem with question 13? Okay, so what I might quickly do, all of these bit kind of questions are highly likely on the exam. So you need to understand how to do the 3 or 4 things. So you've got 4 operations with bits. So firstly, you should know how to convert from hex to binary really quickly, as we showed in the labs. You should be able to do this in, I don't know, less than a minute. So if we have a car bit test equals 0x03, it is the same as saying it equals 3 in decimal. And it is the same as saying 0, 0, 0, 0, 0, 0, 1, 1, or 3 in binary. Okay? Now, the operations that you need to understand how to do with this, is firstly the bit operations. So AND, OR, XOR, and bitwise NOT. So these are called bitwise operations. And then this is a conditional AND, conditional OR, and a conditional NOT. Okay? These get evaluated down to a 1 or 0, as we've shown in many, many labs. So if this is true, it will become a 1. If it's false, it will become a 0. If this is true, it will become a 1, else it will become a 0. If this is true, if this is true, it will become a 0. If it's false, it will become a 1. Okay? So I'm pretty sure you're okay with conditionals. Now we don't have a conditional XOR. You can make one if you need it, out of ORs and ANDs. However, with all of these, when we've got 2 sets of bits, except for this one, so let's look at these 2 first. These are, now I'll be careful with how I use this. So the term binary means between 2. So all your operations are between 2 things, except for the ternary operator, where you've got that, and that's between 3 things. But all your other operations are between 2 things. So here, and then you've got unary operators like this. So these are all between two things. So if I have 0, B, 0, 0, 1, 0, 1, 0, 1, 1, 1, those are too many, no problem. And what I do then is go there, there. Something like that. And then I create another set of binary numbers. 0B, 0, 0, 1, 1, 0, 0, 1, 1. And do that again. So let's have a look at how each of the three operations evaluate. So here, I'm just going to move them over. I've got three sets of binary numbers. I'm pretty sure you're all familiar with binary by now. If you're not, let me know. So the first thing we're going to look at, and, or, and then XOR. So the difference between the conditional operations and the, so actually we might actually do that. So what I might do is grab these two. Yeah. This is actually a fairly good question. So can everyone, so let's call this, let's go across. Let's call this A, B, C, and let's call this I and double I. So can everyone tell me what these two evaluate to? What they would become? So put it in the chat what you think they would evaluate to if we use conditionals rather than bitwise. For I and double I. Or 1 and 2. Have a guess. Just help communicate. So I'm not just talking. Is there anyone else? Anyone else want to have a go? Okay, so they both evaluate to 1. Okay, the reason being is, let's go back a step. So if I have, if 4 is greater than 3 and 2 is greater than 1. The first two things that are evaluated are these. Okay, everything is represented as a number. 4 is greater than 3, evaluates to a 1. 2 is greater than 1, evaluates to a 1. 1 and 1 is true. Now, what about if I had 4? Oh, wait. Let's get back a step. If I evaluate that, 1 and 1, we get a 1 because it's true. Okay? So if 1, which means that the operation would execute. If, on the other hand, this was, let's say, -1, this would evaluate to a 0. Now, 1 and 0 evaluates to 0. Now, what if I had, if 2 is greater than 1 and 4? So we have on the left-hand side a 1 and 4. Is this true? Yes, it is true. So we would evaluate to 1. Why is it true? Because true is basically not 0, and false is 0. So this is true, and this is true. So this is true. So if you want to test this, you can do an if statement and go if 0, see what happens. It won't go in there. If you do if 1, it will go in there. If you do if 104, it will go in there. Okay? Because this is not 0. This is true. So if we go back down to our other cases, down here, is this not 0? Yes, it's not 0. So if it's true. Is this not 0? Yes, so it's true. So it's going to be evaluated down to a 1. Okay, so if I had if 0b1101 and 0b1011, it would go in there because this is true, because these are both not 0. He doesn't care what these are because they're just not 0. If I had 0b, so binary, here, then it wouldn't go in there because now we've got a 0 here. So they're both not true. If I had equals equals, then that would not be true because they're not equal. Okay? So down here, this would be true. The same thing happens here. We've got a true or a true. So we get a true, and we get a 1. So just be careful with these. If you use the wrong operator, you're likely to just get a 1 or a 0. Okay. So these are conditional. Conditionals are just evaluating numbers. And they just basically work by this simple rule. Okay? And any condition will get evaluated to a 1 or a 0. And then it will continue using this rule. All right? On the other hand, we have binary operations. So, can everyone put their answers to all of these, A, B, and C, in the chat? And I need you to participate because I need to know what people know and don't know, and what they're just guessing. So do A, B, and C. So everyone should have a go at this if you're watching. Put your answers in the chat, please. Oh, wait. I'll give you a couple of minutes. All right, cool. All right, so I think most of the people that commented got it right. So bitwise is looking at bits, and that's why it's called bitwise. So every operation is done between both the bits. So you can think of it, if you want, we need more room. No, that's in a different layer. Of course it is. So a good way to think about this is what you can do if you really feel like it. You can take both of these and put them long ways. So we've got 1, 0, 1, 1, and then we've got 0, 0, 1, 1, 0, 1, 1. Now we can compare each of the bits. So this bit here is this bit here. So this is the most significant bit. All right, this is the least significant bit, which is this bit here. So now we're doing an AND between every single one of these. A bitwise AND. So we have a 0 and 0 is a 0. A 0 and a 0 is a 0. Actually, what I might do first. So AND works like this. If you've got a 0 and a 0, you get a 0. If you've got a 0 and a 1, you get a 0. If you've got a 1 and a 0, you get a 0. And if you've got a 1 and a 1, you get a 1. So that's the truth table for AND. So if a 1 and a 1, we get a 1. A 0 and a 1, we get a 0. A 1 and a 0, we get a 0. A 0 and a 0, we get a 0. A 1 and a 1, we get a 1. A 1 and a 1, we get a 1. So the answer would be 0, 0, 1, 0, 0, 0, 1, 1. Okay, does anyone have any problems with that? Cool. All right, so we'll go through the other ones fairly quickly. So, or on the other hand, it's a 1 or a 0 or both ones. So we would look at each of these bits and do an OR between each individual bit. So we've got 0, 0, 1, 1, 1, 0, 1, 1. 0, 0, 1, 1, 1, 0, 1, 1. Cool. I think most people got that. And then the last one, which yep, you got right as well. Cool. Is the XOR, or you can think of it as actually, I'll show you that in a sec. So the XOR is similar to the OR, except for it an exclusive, however you spell exclusive, exclusive OR, meaning that it's either if one is true and the other's false, or one is true and the other's false. So this is also a 0. Okay? And it's with the little caret. So here we get 0, 0, 0, 1, 1, 0, 0, 0. So our answer would be 0, 0, 0, 1, 1, 0, 0, 0. Now these are all operations between two things. We also have the unary operation known as bitwise NOT. So that occurs on one thing. So in the wrong layer. So with NOT, you need to be careful of the size. Okay, so in this case, we're looking at a car, but I'll show you what I mean in a second. So all NOT will do, well, we don't need 3 because they're all going to be the same. If we've got a 0, it will replace it with a 1. If there's a 1, it will replace it with a 0. Now, why I say be careful with this is because let's say I have int x equals 0b 0, 0, 1, 1. And then I say x becomes bitwise not x. Can you write down your answer? Of what x is at this point? And we're assuming we're using the same Unix environment that we're using, the 32-bit Unix environment. Any more guesses? Beautiful. We have one right answer. All right. Now, this is why I said be careful. This is an int. On our system, this is 4 bytes. Okay? So this means, so for every byte, there is 8 bits. So our number, even though we've specified it only using 4 bits, it still has a whole heap of bits before it. In this case, it has 8 times 4 bits, 32. So x at the start actually equals 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1. So if I apply a NOT to that, it's not just this first byte that gets knotted, it's the whole int. So we get 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. 1, 1, 1, 1, 1, 1, 1, 1, 0, 0. Okay? So just something to be wary of. Now, if I use, and this is why here it's a car, because it's only 8 bits. Okay? So don't forget that. But in this case, we have a car, so we don't have to worry about them 8 bits. But if we use an int, more trouble. Okay. And don't worry about doubles or floats for bitwise stuff unless you're crazy. All right. So we'll get back to that question. Yeah, I think that has mostly everything. So the other thing with bits is there's some common operations that you will do with bits. And these are setting, clearing, the toggling, and testing. Testing is kind of separate because it's a condition, but we can look at each one of these. So, what is the answer to question 2? I don't know the answers. Oh, well, that's an easy one. All right, we can go back to question 10. It'll take 2 seconds. All right, so we're getting setting, clearing, toggling. So here, setting, we have whatever our thing is. It could be bit flags or lock or whatever. Let's just call it X. So we've got int X equals 4. So in binary, we know, actually, I'm going to use car as well for the same reason I used before. So we know this would be 0, 0, 0, 0, 1, 0, 0. It's a binary representation of 4. So now if I wanted to set, let's say, this bit here, I can simply do that by going X or that. What am I doing? 1 shifted 2. So this is bit 0, 1, 2, 3, 4. So I should shift it 4 places. And then this would get set to a 1. So now our number is 0, 0, 0, 1, 0, 1, 0. Okay, so that is setting a bit. Okay, and if we have a look at it, if we break this open and go X equals X for 1 shifted 4 places, we've got on this side, we have 0, 0, 0, 0, 0, 1, 0, 0, and then we have an OR, and then we have the 2 operations. So we've got 0, 0, 0, 0, 0, 0, 0, 1, shifted 4 places. So if I shift this 4 places, I go 1 place, 2 place, 3 place. So this is shifting it to the left. So it shifts the whole thing to the left. We haven't really done much with the shift operator. This is probably as far as you really need to go in preparation for the exam, but you should understand what it means. I don't know why I put brackets there. Ignore that. Okay. And now it's just doing it all. And as we saw before, if it's a 0 or 1, so we end up with 1, 0, 1, 0, 0. Yep. Okay, we end up with the right answer. So this is setting. Okay, so you can just remember that for setting a bit. And I would recommend knowing that for the exam. Hint. Oops. All right, the next one's clearing. So clearing's an interesting one. We have and equals not clear this bit now. So I want to make this 0. 1 shifted 4 places. So this would result in 0, 0, 0, 0, 0, 1, 0, 0. So we'd end up back at the same number we had before. Okay? And I will leave it as a task for you to open this up unless you really need me to explain it. And then toggling will basically, if it's a 1, it will change it to a 0. And if it's a 0, it will change it to a 1. So if I do x toggle 1 to 4, and I do x toggle 1 to 2, then the first operation will change this back to a 1, and then the second operation will change that to a 0. Okay? Make sure you understand all of those before the exam. It's just an and. So we just already looked at that. It's testing if a certain bit is set. Okay. Now, question 10. Okay, can everyone give me the answer to question 10? You get this wrong. So this is something we did in very early weeks. So you can have a go at it, and then we'll explain it.
Matt,
Yep.
while discussing these questions, the answer for this question was given at 0.
Yes.
Okay, but when I tried doing this program, the answer what I'm getting is 0.6 times 0.
Oh, you mean the floating point number?
Yes.
Yeah. Yeah. You get 6 zeros.
Yeah. So, I mean, yeah, 0 and 0.6 times 0. So both are same. I mean, the value is 0 only. But
Yeah.
if suppose this question comes in the exam, for example, like I'm just saying,
As
then
long as
what answer are you expecting? 0
as
or
long
0.6 times 0?
at least 0 point and then a couple of zeros. We're not expecting you to memorize how many zeros are in the format specifier, but we are expecting that you understand that it's printing out as a floating point number.
Yeah, so the answer is not 0, but it is 0.0, right?
Yeah.
Yeah, okay. That's what I wanted to clear. Thanks.
Yep, that's all good. Sorry about that. All right. More questions? Any of the practice exams or the quiz questions or anything like that? As I said, the quiz questions are really, really, really good practice tools. You should try and do that a couple of 100 times before the exam. Not 100, but a good amount before the exam. So if there's any questions from that either as well, let me know. Because you've got the quiz questions that you can just try as many times as you like there. So don't forget that. Have we got more questions? Raise your questions. Past exams. I know a couple of people want stuff from past exams. How to do this? Okay. In a simple case. Give me a sec. Where's this question from? No. Ah, cool. Okay. So this question, where is this question from? Because it's wrong. Chris, okay. Can you tell me which question? Because there's actually a mistake in it. Or can you email Josh? Note the mistake if we're not using C 99. This one. So I'm just going to fix this up. Because we're using the older version of C, we need to declare C here. Okay. So there was a little mistake in that. All right. So let's have a look at this. So up here, we have some function, a main function. We have our array. So S1, and it's of type car. And we have 1, 2. How many characters? Can you, in the chat, type how many characters are there? Before I draw it. Just write the number of characters. What? 6. Good. Okay, there are 6 characters. If you're using a string, you have the null terminating character at the end. Okay. So we have A, B, C, D, and 5. Okay. And this is in some function above, probably main. And then we call our func. So the first thing that our func does is it creates a variable called car star s. Now, this is also a car star, because it's a pointer, this S1. So we have S, which is a car star, and we pass this to here. Now, this is the same as the example we did before. It passes the value, so it passes this pointer. So now this pointer points here. And I really should be careful about using arrows and pointer values. Okay? Because we are passing the value of S1. The value of S1 is a pointer that points to the start of the array. So do not forget that your array, the S1 by itself, is a pointer to the start of the array. Okay. Then we create another variable called car C. So it's C and it's a car. And we don't know what's held in there at the moment. We then get to the for loop. Now, if you remember, our for loop, we'll do this one first. Then it will do the condition. Then it will do some code. And then it will come back up and do the incremental, whatever's here. So the C is initialized to dereference S. So if we dereference S, we get an A. Is A. Then we go here and we do the same thing again. So C becomes dereference S. Dereference S, remember, if we're dereferencing, we just follow the line and grab the value. So 1 star. It's not the micro. And grab the value there. Okay? So now we have this A, and then we do the exact same thing again. Okay, so we've got the A there. Then we're saying if C is greater or equal to A, and C is greater or equal to Z, then we add 32. Now, I think he put a hint in this question, because if we have a look at the ASCII table, I think the question's complete, but okay. So if we add 32 to a number, so let's say we have 70, we have an F as a capital. If I add 32 to F, I get 102. So it gives the lowercase letter. It'd be a bit hard to see. So F is 70. If I add 32, I get lowercase f. All right. So here, if C is greater or equal to A, C is equal to A, so we don't even need to evaluate. And it's less than Z, so that's fine. So we're saying dereference S. So we're looking at this and add 32. So as we saw in the ASCII table, we convert this to a lowercase a. Okay. Where are we? Yeah. Then, so we've done that. Now we say if C is greater or equal to 1 and C is less than or equal to 9. So if we have a look at our ASCII table again, we know that the letter A is not between 0 and 9. Okay, because 0 and 9 is between 48 and 57. So this isn't evaluated. And this would be evaluated to a 0, and this would be evaluated to a 0, and we get 2 8s. Okay. And then we get the 0. All right. So we've done that, and then we go up, and then we increment S. So we're incrementing the pointers, what the pointer is pointing to. So now, pointer points to the next thing. We then dereference, then we check that the dereference S is greater than 0. Remembering the null terminating character is 0. So we can also look at that in the ASCII table. So this is the null terminating character. It is 0. So now we know that capital B is between A and Z. So this would become a lowercase. It is not a number, so it's not between 1 and 9. The character's 1 and 9, so that's fine. We then go back, increment, look at the next one. And we get C. It's neither between A and Z capital, and it's neither between 1 and 9 as numbers. We then go to the next one, because we're just incrementing, and it's not 0. So this here, D, is not uppercase, and it's not a number, so we keep going. No, there won't be any ASCII table during the exam. I don't think you'll need it. I'll double check. I'll have a look what's on the exam in a sec, and I'll double check that you don't need it. And then we have a 5. Is 1 and 9 between 5? If we look at the ASCII table, it is. Now, even without the ASCII table, you should still understand that the numbers and letters are all together. Okay? So we have a 5. So we need to decrement by 1. Now we can use that by going to 52 and we get a 4. Or you can just know that the characters are in order. So this would become a 4. Then we increment. We get to the null terminating character. Okay? And now we see that S, dereferenced S, is not greater than 0 because it is 0. And we end this function, and we return, and we print A, B, C, D, 4. Does that help? Cool. Let's have a 5-minute break, and I'm going to check, while we do that, I'll check the exam and make sure there's nothing that you'd need the whole ASCII table for. So go have a 5-minute break, and we'll be back. Later. And also check your questions when you've got them. Okay.
Matt, also after the break, can you please explain for postgraduate students, there is going to be some extra question. So what type of question that would be?
Did you go to the lecture?
Yeah, but I don't remember it was explained.
It was, and it's in the lecture notes. If you go to week 12, it tells you exactly what's on the exam for everyone.
Yeah. But I guess he said it's going to be some programming question.
Yeah.
Yeah, so what sort of like do we have to draw some diagrams or write the entire program or something like that? That's it.
Everyone needs to write their own program. So let's have a break and then I'll come back to it, all right?
Sure, yeah, thanks.
Okay, can you hear me? Yep, cool. All right, I just had a look at the exam. You won't need the ASCII table at all. Okay, so don't worry about that. Now, in week 12 tab, it tells you exactly what questions will be on the exam. So that's what the front of the exam will look like. There is 120 marks. There is 20 pages. I think that's correct. It's 120 minutes, so mark per minute, 15 minutes reading time, and so on. And you've got students from non-English speaking backgrounds can bring an unmarked non-electronic translation dictionary into the exam. Okay. So, first type of question is going to be multiple choice questions. Pretty much just give a tick to the right answer. So, which of the following cannot be used as an arithmetic operation in C? So, the and, because it's a conditional, well, it's a bitwise and outputs from programs and code fragments. So as you see, these look very similar to questions like the quiz. And so if you want to get good marks in this section, do the quizzes a lot. Okay. Same with the multiple choice, but the multiple choice is going to be more based on the lectures. The outputs from the program are going to be similar to what you've seen the whole semester in the quizzes. Okay. So what is the output of this code fragment? Gives you the code fragment, and then you give the answer. Okay. All right. The third type is the box and pointer diagrams. So in week 12, do I still have it here? In the lab, this is exactly how the question will be written in the exam, okay? Except for there'll be less parts. You won't have to do this long of one. This one has 11. I think the one in the exam has like 6 or 8 or 7 or something like that. But it will give you the code like this, and then it will say something like this. You need to show it immediately after the execution. So this is why the A++, it really doesn't matter. And then you'll have a code block for each one. And as you saw in the lab, you will need to do a lot of repetition. And I think, give me 2 seconds. I'm pretty sure Ash, oh my God, what is going on? Okay, I need to post the answer. I don't know why the answer is not there. I'll put the answer for this one up on LMS as well. It was meant to be up there. I don't know why it's not. But I will put that up. But this is how it'll look. So you'll do each single one. There will be a lot of redrawing as we saw in the lab. So be aware of that. But we'll put the answer up so that you can see how it needs to be written. But it will be a small block and you do all the same steps at the same time. They shouldn't interfere with each other, so it's not a big problem, okay? So small blocks, and you will need to draw the whole memory diagram again. You can take a couple of shortcuts if you show your assumptions and stuff like that. So hang up, there we go. All right, so the next thing is interpreting errors. So usually in exams, there's always going to be questions to test some of the students that are right at the top. And these questions will be difficult. So interpreting the diagnostic messages from your compiler. So for this example, invalid type argument of unary star, it has an int. So you're trying to dereference an int in this case. Okay, and then you need to explain how it could possibly be fixed. So in this case, there's two ways that it could possibly be fixed. The first way is to remove the star and treat it as an int. Or if you meant to use it as a pointer, then you'd need to declare the variable as a pointer by having int star in the variable name. Okay, so it will be, you need to explain what the error warning is telling you, and then how you could fix it. And some will have multiple ways you could possibly fix it. All right. The next one is the flowchart or flow diagram. So we've seen that quite a bit, and there's a whole lecture on it. And there's a whole heap of diagrams on week 6 or whatever. And you also saw it in the assignment. So given some piece of code, you may have to draw one, or given some problem description, you may have to draw one, or you may have to write some code from a diagram. Most likely you're going to have to draw one though. Okay, so get used to drawing it. Get some small code fragments from the quiz or from random labs and try and draw them out as flowcharts. Okay, that's probably the best practice you can get for that. It's not a hard question, but you need to know how to draw those properly. Okay, so make sure you look at the diagrams. The next one is a complete program. Okay, now, okay, so this one, everyone needs to do and is worth quite a lot of your exam. It will not be like the labs where you're given instructions, rather you'll be given the problem, and you need to write the code to solve the problem. Okay, to get practice at this, you just, why am I? Oh, to get practice with this, you just need to try and do some of the labs without instructions, or just try and find problems and solve them. This is testing your problem solving ability and some of your coding. It's not going to be an overly complex program. You're given a page and a half, so it's not very long, but you will need to write code for this. Okay. The last one, if you are doing CSC 5 CES instead of PES, your front of your exam is going to look slightly different. So you're going to have 150 minutes rather than 120, and there'll be 150 marks in total. Okay, this means that the extra question is worth quite a lot, okay, as you probably can tell. So it's a whole extra half an hour. So given a program, describe what the program does and what the identified statements do. So in this type of question, you're going to be given a big piece of code, and random points are going to be pointed at in the code, and you need to explain what they do, and you need to read the whole code and explain what it does overall. Okay, so grab some random bits of code and see if you can explain it to practice. Okay, so just, I don't know, get a big piece of code out that you've done, get rid of the comments, and then just pick a random number and go, do I know what this statement is talking about? Do I know what this line's talking about? Do I know what this line's talking about? Okay. So does that answer your question? Cool. All All right. So, where are we? We're back. No. All right. So the next question we had was a fairly good one. I wonder if I copy and paste it. Give it a sec. Copy. Open this. Erase. Cool. So we got some code here. And the question was, why does it equal 5? So what I'm going to do is look at this in a couple of cases. So I'm going to take that case. I'm going to take this case. Then I'm going to take, oops, didn't mean to do that. This case, and I'm going to take this case. All right, so we've got 4 cases there. Cool. So we have A, B, C, and D. Let's have a look at A first. So actually, let's have a look at the simplest one first. Let's look at C first. So here we have some simple code. We have int x equals 5. So we have x, and it's worth 5. And then we increment it. So we get 6. Remember, post or pre doesn't really matter when it's only by itself. So x is equal to 6. And then we print out 6. Okay, cool. So in this case, we have x is 6. Okay, now let's have a look at this case. So remember that your code first goes through a precompiler and then a compiler. Now a precompiler will, what's it called? Evaluate all your macros. Okay, so this is kind of a bad example for this, but basically all your defines will get evaluated. Now there is no macro in this code. Okay, so basically this is gone once it's compiled. Okay, so now we're left with int x equals 5 plus x printf star d. So we can see that in this case it would equal 6 too. But what I might do, I don't think I meant to erase it that much. So this line here would be evaluated and it's not being used, so it's gone once it's precompiled. So all your defines are gone once it's precompiled. So we get left with x equals 6. Okay. Now, in this case, here, in the precompiler, it goes, is macro defined? So if defined macro, it's bad English, but if macro is defined. So if it is defined, then it will include this part of the code. Well, this part of the code. If it's not defined, then this is all gone. Okay? Now, this is really important that you understand that with the precompiler, this is actually removed from the code when we compile it. So we actually get a smaller executable, okay? Because this is not included. So in this case, we have int x equals 5 and then printf. So in this case, it would print 5. In this case, however, we evaluate macro. We find that macro is defined. So this part does get included. Now, all of this is gone after precompiling. All of this is gone, and all of this is gone because it's been evaluated, okay? So we get left with int x equals 5 plus x, printf. So we have the same code as this after it's precompiled. We get 6. That answer your question? So you basically, so if def is just checking if this is defined. If it's not defined, then that part of the code is not included.
Matt, I have a question. As of now, we have
Yes.
we are using macros to replace certain integer value with that macro value, right?
Part? What'd you say?
As of now,
Yep.
we are using the macros just to replace the value with.
Yes. We're not doing, so you can do macro functions as well, but we didn't really cover it because.
Yeah. So considering the code which we just saw right now, the first one, the A case, okay. So in that case, what is the use of such macros when, I mean, there's no value which is assigned to that macro as such to get replaced with. So what is the use of such macros?
For if defs.
Okay.
For if defined. So there's multiple uses of this. So for example, this is used often for a couple of things. So I don't want to get too complex, but let's say we've talked about 32-bit and 64-bit architecture, right? Yeah. So your ints are going to be 32 if we're using a 32-bit architecture and it's 64. Okay. So up the top, you'll have hash define arc 32, let's say. Okay, because we're using a 32-bit. Then we'll have if def arc 32. Then we define, I don't know, int size to 32. Else hash define int size to 64. There may be other cases. So in your code, let's say if def arc 32, then you may have to do a special operation. So let's say a equals 1 shifted 32 places for some strange reason. So a lot of the time, if you go have a look at some larger codes, you'll see that you can change some of the options based on the hardware or the software or the version. So another example might be if you're using version 2, then it may change something in the code compared to if you're using version 3 of, say, Photoshop or something like that. It may change something in the code. So it allows you to still use old versions of programs, let's say. So it does become useful. It's a bit hard to demonstrate now because we haven't gone that deep into how it can be used. But this is a reasonable example of how it could be used. And you will see it a lot. However, the reasoning's usually fairly domain specific. So it's good to understand. The other one that we have used and should be fairly common is hash define debug. Okay, so if you're debugging, you don't want the debug code to be in your your final release. So you definitely want to make sure that that's done with macros so that you keep the code size down. Okay, because this debugging information, once you get rid of this and you send the executable off, this will not be included as part of the code. It will not be in the executable at all. No one can ever get it. We can also extend this, so we could have debug, let's say, logging. Actually, debug, that's actually a good example as well. Debug input. And then you could have another one, hash define, debug output. So you've got multiple debugging, for example. Another example is, in a lot of cases, what you want to do is not print stuff to the screen, but what you want to do is create a report. So this is really important when testing. So if we're doing, let's say, white box or black box testing, specifically white box, a lot of the time it's silly to print that out to the screen because a user has to sit there and watch it. So what you want to do is have log files. So if define white box log, and then what you do in that case is, if that's defined, then you save all your outputs to a file so that someone can test them later and check if they were right or wrong or something like that. So it does come in very handy. Does that help? All right. So, more questions. Has anyone looked at the previous exams? Is there anything on them? They also have some really good, I don't want to give away too many of their answers because they actually have some really good questions. We went through one last time. I'm going to pull one up. Where are we? Let's see, yes, PS. Cool. All right, so these kind of questions are just like similar to the, what's it called, quiz questions. Now, a question like this is really good practice for the last question. It's simpler than the last question because it's only worth 15 marks, but these are the kind of questions that you should be able to write some code for. And we went through this exact example last week. I might go grab another exam and go through another one similar. There won't be any of them. With this question. So this is a really good question as well. So write a function that takes the following arguments: a struct, an integer, and stores the number of houses in an array. The function prints out the address and price of every house that has 4 or more bedrooms. Function prototype is shown as below. If the array contains this, then we call print large houses as follows, and then it'll print it out. So maybe if we get time, we'll go through this as well. And then you've got discount houses. This is actually a really good question. I might do this one as well, but I just want to see if there's any other questions in the previous exams that are also similar. Same question. Okay, so I might go through this one. Once again, it's a fairly easy question. But let's have a look at it. So I showed you how last week also how I would go about this. So what I do is do that and then open print. This. Okay. There's our chat section. Would you like me to go through this question? Or is this easy, hard? Let me know. Is anyone else want to go through this, or do you want to go through something else? Okay. All right. Why is it so small? Okay. So, if you watched last week, you would have seen the way I go about this. So, firstly, I know I'm writing a function. I know I'm taking a string, and I know I'm returning a number. Now, even if this wasn't given, I could work out what I need based on them three things there. We're looking for the occurrences of the letter A. So, I already know that the first thing is given to me. So I'm going to write it down straight away. So I've got int get num letter A car star input string. Okay, I know it's an int, so I'm going to chuck my return there because I know I have to return something. And I know I need to return an int, and I don't get an int in, so I know I have to declare an int. I don't usually give the variables names till later. It's just the way I go about it. Now, I know it's a string, and I know that I'm looking for the letter A, okay? So I know that I'm going to have to iterate. I know I'm going to have to go through every single one. So I could do this with a for loop. However, I don't know how long the string is. So I don't really want to do it with a for loop, but yeah, we can do it with a for loop. I think I used a while loop last week, so I'll do a for loop instead. So I'm going to use a for loop I know I need. So let's do a for loop. I'm not going to put anything in there yet because I don't want to. Now, I also know that I'm looking for something. So I'm looking for the occurrences of A. So every time I go through, I want to see, is this letter an A? So if something, then we know we need to increment some kind of counter. So that's how I would design the code. I would just work out what's my conditions and what's my loops. Okay, I wouldn't worry about the variables at this stage. I wouldn't worry what's inside of these. I'd look for all my loops and conditions first. Okay, because that's where your real logic lies. Unless it's a mathy question, most of the logic is in loops and conditions. So ifs and fors or whiles. Okay. So generally, if it was a question like this, if it was a longer one, there'd just be lots of fors and ifs. And when I'm designing code, I will do the fors and ifs first before I put any variables in, just so that I can make sense of what's happening. So in here, I know I'm going to look through a string, so I'm iterating, and I know I'm looking for something particular, so it's an if. Then I can fill in the blanks. So I know I need a counter, so let's call it counter, and I know I initialize it as 0 because if, well, we're counting the number of A's, and at the start, the counter is going to be 0. I know I need to return the counter. I know I need to increment the counter if it finds an A, and that's all I need from the counter. Then I'm going to go through my loop. So I'm going to set I to 0. Now, did I do this with... I might do this a different way, actually. What I might do is go input string I not equal to 0. So I'm saying while the input string is not equal to the null terminating character. Because I don't know how long the string is, I need to compare it to the null terminating character to see when it ends. And then my last thing is just going to be I++. Now, because this is a pointer, I can use the I like this. So as I showed you last week, if I have int A 4, that is, and then I go A2 equals 6, that is exactly the same as saying star A plus 2 equals 6. Okay. So this is perfectly fine because we know this is an array. So I can use array notation. Generally, I would avoid this, but I think most people prefer array notation, and that's why I'm using it here. We can do it with pointers if you like. We can do, yeah. All right, so then in here, I would just compare input string I is equal to A. Done. Write a function, now check. Write a function that takes a string as an input and returns the number of occurrences of the letter A. The function prototype is shown as blah, 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 blah. So now we'll test it. I'm not going to test the whole thing. Let's just say the string is apples. Because I'm in an exam, I don't want to waste time. I'm just going to do a simple example, and I'm going to test it. So I've got a pointer to the start of this, which is input string. Okay, it's pointing to this first A. And then I know I've got a null terminating character here. So counter is equal to 0, int I is equal to 0, 4, 0. A is not 0, so that's fine. It's not a null terminating character. Is 0, input string 0 equal to A? Yes. So my counter is now equal to 1. Then I go up, I increment input string 1, so P is not equal to 0. So it continues, and then input string 1 is not equal to A, so it continues and goes around. I can see it's working, and it would return a 1, so I'm happy with that. Okay? Answer that kind of question. Now, if we want to do it with pointer arithmetic instead, let's go on this pen. There's a couple of ways we could go about this. So we could go input string plus I dereferenced is not equal to 0. And we could just go dereference input string plus I. Okay, equals A. And that will work as perfectly the same. Or I can actually increment my input string. Now, what I'd usually do in this case is create, because it's in a function, it doesn't really matter because the pointer is a copy already. So I don't need to actually create a copy because when we have a pointer and we pass it to a function, this is a copy of the pointer. So all I need to do is while star input string is not equal to 0, and then I can go. Now, this is where I could be tricky and do this. And do something. Ooh. Actually, I won't, because it won't work. So input string, and then I'll increment my pointer. Okay. No, I can't do that. And that's how I do it with pointers. Okay, and that should work as well. All right. Any questions? Questions. Okay. Is there any questions in the YouTubes? No. Oh, this is embarrassing. Any questions? Any particular questions you want to go through? I need your input. Okay. So, how did we go about answering this question? Do we want to go through this question? Do we want to finish? Are we all good? I'm not saying no. Is there any particular questions you want to go through? Are we all okay with a question like this?
Matt, I also worked side by side on the same question as question 3. So when I'm trying to run that program, I have given a string, I have hard coded it. So while doing that, actually what I have done is I have given certain size to an array.
Yep.
Yeah. And I'm just trying to put some string into it. Okay. So if suppose I have specified the size of an array to 6 and I'm giving the string which is greater than of that length, so should it give me some error or something else because it is printing some random characters?
Wait, so you're expecting it to be 6?
No. I know it is not 6 because the string which I have given is apple.
Yep.
So it is more than that. Yeah.
Why
So after
6? Why 6?
sorry?
What's 6 have to do? Why 6?
No. Because earlier I had given a string to be apple.
Yep.
So 5 letters of apple and a \0 is 6. Okay.
Yep.
So yeah. So now when I'm keeping the size same, but I'm giving the string apple. So should it give me the error or because it is printing some random characters like sometimes @ symbol, sometimes some box, something like that.
Can you show your code?
Yeah. Yeah. Just a sec.
I cannot see anything. Wow. Okay. So your problem has nothing to do with your occurrences. It has to do with your. So I'll put your code in here. All right. All right. So your problem is not in your occurrence function. It's actually in main. So the problem is your initializer. You've said that this is 6 characters long, but you've got excess elements.
Yeah.
Now, if you use -wall, you should have picked up this error. Did you use wall? Warning alls? So what it is doing is it is storing the first 6 and it doesn't store the null terminating character because it can't because it's too far away. Okay. So it's storing apple A, as you can see in your output. And then because there's no null terminating character, it's just going to look through random bits of memory and print them out until it reaches a 0 or it segfaults.
Okay. So if that is the case, then every time I try to run this code, I might get some other weird characters to be printed on the screen, right? Not necessarily all the time I should get the same symbols which are like sometimes
No, sometimes you may actually segfault. So to fix that, just get rid of the 6.
Yeah. I just wanted to check out because what Somnath discussed during the lecture was like there could be some
So you can just do
questions where
that.
you have to answer certain questions like how would you rectify the error and all that stuff.
Yes,
So just
I
wanted to
said that.
try out.
Yeah, so you can just redo that.
Yeah.
So that one way would be to let the initializer define how long the array is, or you could count and have the number of letters there, or you could reduce the number of letters in your string.
And one more thing is, if suppose I give spaces like apple space, and like every time I give space, then that is counted for the array, right?
Yep, it's part of the string.
Yeah.
So remember the first ever string we touched was what?
I didn't get you.
What was the first string we ever printed in our C programs?
Hello world.
Hello world. And that has a space. Oh, if I can spell. Okay.
Yeah.
Space is part of the string. So a space is an ASCII character. So
I guess it has 32.
Now, spaces sometimes can be treated differently with some functions. But in general, yes, it is an ASCII character. Oh, what did you do that? No, don't worry about the number. But yeah. Cool. Do not memorize the ASCII table. There's no point. It's not going to help you. It's not made to be memorized. It's not the point of it. Yeah. All right. I think there's not really any more questions. So I think people are leaving. So I might wrap up there. Yeah, I think everyone's just left. All right, so we might finish up there. The next session will be. I can't remember what I said. What did I say?
Matt, whether the session is at 8 or 8:30?
I was just running late.
Okay. I thought the timing has been changed.
You know,
That's fine.
I had to go drive somewhere and I came back late, so didn't have time for dinner.
That's fine.
At times. That's it. Sessions. So next one will be the 4th. So that's Friday. That's tomorrow. Cool. We'll do one at 8 p.m. tomorrow as well. And then, wait. Yeah, that's right, Friday. Cool. So bring your questions along. All right, we'll finish up there. Thank you very much. And bye-bye.